Everybody. This is Unit 2, Lesson 7. So as usual, please look for the tasks to complete for U2L7. You can either find it under Assignments or on the Science2 Canvas homepage in the weekly calendar. Today's date is the 5th of November. Remember the 5th of November. You should all watch V for Vendetta, if anyone's a V for Vendetta fan. All right, we're going to start off today with the usual pairings. This time the questions are actually going to relate to the homework. So I'll throw the questions in the chat, though you can also see them on the tasks to complete. We'll do 2 rounds this time around. They'll be pretty quick. So first one is going to be, here it is in the chat. Make sure I'm chatting it to everyone. Wait. Wow, weird. Okay. So the question is, do you think old satellites should be deorbited or pushed into disposal orbit? So think about what you posted in your discussion board. Though honestly, if your mind has changed, that's okay too. So just share your answer and share your reasons why. We'll come back together in about 1.5 minutes. Hi, Alina. How you doing?
Hi, sorry I'm late.
All good. All right, you should still be able to fit into a breakout room. All right, breakout rooms are open. Go for it. But you use that more simple orbit simulator in our previous, one of our previous classes. I now want to use one that is designed by PhET, which is a little bit fancier. Just to give you a quick preview here, so this is what it'll look like. You're going to select the model version. It'll give you 2 options, model and to scale. You're going to start with model. The first thing you're going to start with, actually in the upper right corner here, you're going to go with Earth and the Moon. And you just hit play and it'll begin its orbit. Note that it gives you the amount of time it takes to make a full rotation, and time just continues. You can fast forward if you get impatient and you want to see how things are moving. And then there's a bunch of settings here you can mess with. You can show the path, which is something I'll have you do. You can select the velocity and gravity force indicators. Not surprising, the velocity is pointing tangentially, and the gravitational force you can see pointing inside. But there's some other cool details here that you'll explore using the quiz. I think you've got about 5 questions relating to that, and then you're gonna, on the lower menu, click to scale, and you'll notice that things are much, much smaller and much, much farther away. Even if you had Earth and the Moon, that's what it would actually look like to scale. But again, you can do kind of the same activities and you'll answer some questions here. So the quiz looks like this. Let me go back to the quiz itself. Every question has a set of instructions on what to do, and then you can answer those questions based on what you observe. So again, I'm going to time for about 15 minutes, but I'll keep an eye on completion rates, and let me know if you are stuck or have questions. 15 minutes to use the simulation, complete the quiz. Go for it. Dragging the moon along. I never thought of it that way. And if you look at the velocity that the moon is moving, it kind of slows down, speeds up, slows down. It's almost like someone's stitching something as it goes along. Just kind of an interesting perspective to take. You know, we're so used to just thinking of the moon going around Earth, but in reality, it's sort of bringing it along with it as it's orbiting. And it kind of makes me think of the marbles that the guy was throwing onto the spandex pad a little bit too. Okay, you got into the actual then, like, to scale size, where everything was a little smaller, a little more distant, and you got the planet into an elliptical orbit. What did you notice about the velocity and the gravitational force when the planet got close to the star? Did they increase or decrease? Who's got an idea? When the planet got closer to the star in the elliptical orbit. Matthew, what did you notice? Did they increase or decrease as they got closer to the star?
I don't really, I think it increased, right?
Yes, right? So the minute it approaches or gets closer to the source of gravity, it's going to go faster because that gravitational force is pulling it towards the center, but it never actually collides with the star. It just gets sort of slingshot around. That's how I think about it, right? The gravity really pulls it in, that increases its speed, and then it gets shot out again, and that elliptical orbit slows down as it gets further away and then gets drawn back in. So that's an important thing to understand about how elliptical orbits work. Finally, you had to change the mass of the planet, right? So I think the scale, it's 1.5 and 2. What I think that means is 2 times the mass, right? So you did that to the star, and that's what got it in the elliptical orbit. But did anyone notice when you changed the mass of the planet, did anything change to the orbit? Yeah, see a lot of nodding heads. Nothing changed. Anyone know why? Why would changing the mass of the star draw the planet closer, but then when we change the mass of the planet, nothing happens? Sophia, you got a guess?
Because the star or the sun, whatever you want to call it, like has such a big mass, it sort of it like overrides the planet's mass. So yeah, that's it.
Very good, right? It's pretty much insignificant because it's so small, right? And remember that equation, right? Gravitational force is the gravitational constant g times you've got your mass 1, mass 2 over distance squared, right? This is the gravitational equation we've been learning about. If one of these numbers, like that one, the star, is huge, right, 1,000,000, it really doesn't matter what the value of this is then if it's really, really small, whether it's 1 or 2. It's not going to make a huge, huge impact on the math overall. And that's exactly what you're seeing, right? By even doubling the mass of that planet, it's so small compared to the star. That's why it doesn't make a difference to the gravitational, the orbit. Now, if this simulation was a little more detailed, you might see a slight difference, or if we were taking measurements, you would see a little bit of a difference. But for our understanding, that's kind of another good takeaway from that. So, all right, any other questions or comments on that? All righty, kiddos. What's going to happen the next time we meet?
Test.
We are having our Unit 2 test, okay? It's going to be exactly the same as the first one. No time limit. It's completely open notes. I'm going to provide a study guide and review slides as soon as I can. I'm still putting them together, but those should be done by tonight. And what else was I going to mention? Oh, it's going to cover pretty much all of Chapter 5, right, from Hewitt. So starting with gravity, even some of the older stuff that we talked about in our previous unit, tangential velocity and the inverse square law and that kind of thing. But again, that'll all be there, and you'll have open notes to refer to. So the only homework is making sure you've completed these 2 things we did in class and studying for the test. Any questions on that? All right, kids, that is it for me. Thank you very much. Have a good day.
Thank you.
Thank you.